Hello guys, so welcome back to our channel. So this will be our next tutorial for today. I'll be teaching you on how to make a animation. So this is a moving animation using the MIT App Inventor. So this will be the expected output of our project for today. So this is the Super Mario. We have here a play button. So when we click the play button, Mario will start to run on our platform, and we also have the mountain moving on the background, and also the cloud moving on the background, right? So this will be the expected output. And you also have when you click or touch the screen, so Super Mario will jump. This will be the expected output, and we will be focusing today with the animation on how to make Mario move, on how the mountain move, and on how to make the our clouds move. So to continue, this will be the expected code blocks, and for our designer view, this will be the expected designer view. So we have here the platform, so everything will be uploaded in our project, right? So to begin with, let's have a new project. So let's start a new project. So the project name is exercise number 7 underscore your last name, first name, and your middle initial. Click OK. So we are now in our new screen, and also our I'm using the BlueStack emulator for our live output or live testing of our project. So first is, let's have a canvas. So in our drawing and animation, let's drag a canvas, and let's adjust the height to fill parent and the width to fill parent. And for this screen, let's have the align horizontal to center. And for the canvas, let's have a image sprite. So this will be for the platform number 1, platform number 2. We also have for Super Mario the mountain, the cloud. Okay, so this will be some of our image sprite. So let's have for the platform, rename it as the platform sprite. Click OK. So for this, let's have the picture. Let's upload all the media files first. So we have here the Mario 1, which is the A1, and also have the A2, and then the A3. So this will be for the animation of our character, which is Super Mario. Next is, let's upload the platform. And upload the mountain, the cloud. So we have two cloud, so cloud and the cloud 2. As you can see here, the cloud 2 has a smile. Next is for the play button. This is the play button. And let's upload the jump MP3. Alright, so we have here our media. So for our platform sprite, so let's have the picture to platform. Then for the next, this is the platform 2, platform Sprite 2. Let's connect the MIT AI companion later. So platform 2, right? And next is for the Mario Sprite, and change the picture to A1. The next is for our mountain sprite. Change the picture to the mountain, to BG mountain. And for the last, we have the cloud sprite. And change the picture to the cloud. .png. The next, let's have another one for our start. This is the name to start, and change the picture to the start.png. Okay, and adjust the height to at least 40 pixels, and also the width to 40 pixels. We'll adjust everything later in our code blocks. The next is, let's have a sensors. So we'll be needing at least 1, 2, 3, 4 clock. So the first clock is for our loading clock. The next clock is for our animation clock. We have also the background clock and our jumping clock. So let's rename them. So first is the loading clock. So clock 1, rename it as loading clock, and uncheck the time always fires and time enabled. And for the time interval, so for the loading clock, the time enable should be checked, and for the timer interval should be. So for our loading clock, so time always fires is unchecked, time enabled is checked, and for the time interval we have the 25. The next is for the animation clock. Let's rename the clock to, so the loading clock, time enabled, and we have the 25. And for the clock 2, let's rename it as Ani clock or animation clock, and uncheck the time always fires and timer enabled, and the time interval is 17. And for the clock 3, so we have the BG clock, uncheck both, time interval is 48. And for the clock 4, so we have the jumping clock, uncheck both, and the interval should be 45. And let's have a media sound. This is for the jumping sound of our character, so let's name it as jump. And for the source, let's have the jump.mp3. So that would be our source. And the interval, let's say 500. That is 0.5 seconds. So let's connect again our MIT App Inventor to our AI companion. As you can see here in our output, it is a mess, but later on in our code blocks. So we will arrange them accordingly. And let's go to our code blocks. To start with, let's have a procedure, and rename the procedure to the ini screen, or initializing the screen. So what will happen if we open our application? So first is, let's have the canvas width. So I'll open the Photoshop for just simple explanation. So we have the canvas width. Set the canvas width to, let's have a math. So we will be making our canvas into 3 times of our screen size. So to do that, let's have this multiply, and screen 1 that width times 3. So to explain that, so I have here the Photoshop. So what will happen there? For example, this is my screen. Okay. So what we do is to make this screen times 3. Alright. So that we can use the space of our, or just make a invisible screen. So we have the 1, 2, and 3 screen. So this will be our whole canvas, the canvas 1. That's why in our MIT Inventor, so we make our screen times 3. And then next, let's set the background color. As you can see here, we have a white, a background color. So let's go to canvas 1 and the background color. So in here we can choose the colors from here. We have black, white, but we can also make color and make a list. So this will be the RGB, or the red, green, blue color. So I have the list, so 248, 224, and the 176. So to see the result, let's have this, our example. So this is just a procedure, so it will take effect when we call the procedure in our timer. The next is, we will set our Mario Sprite, the visibility to false, so that in our initialized screen, Super Mario will not be in our play button. So false, and then let's set the platform sprite to true, and also the platform, or the mountain sprite, and the cloud sprite. We'll just duplicate this. Next, let's change the position. Well, let's see if we can. Let's have the loading clock, so that we can see the output of what we are doing. So to do that, let's have the procedure, which is the ini screen. As you can see here, so we have the canvas 1 background color, which is this. So to see the color, let's go to the color picker, and we have the RGB here. So our place is 248, so we have 248, uh, 224, and 176. 224 and 176. So this will be the color of our background. So we have a list, and then let's have the position of each of our components. Let's start with our cloud. So let's duplicate this and set the, we'll set first the height and the width of our component. So cloud sprite that height, and let's set it to the screen height. So let's have a multiply, and let's duplicate this. Instead of width, change it to height and multiply by 0.07, so that's the 7% of the screen height. So that will be the height of our cloud sprite. And then next is for the cloud sprite width. So the cloud sprite width is the cloud height. So let's remove the screen height and let's go to the cloud. So we have the cloud sprite height, so multiply by 2, so it's 2 times the height of our cloud. The next is the platform. So we will set the width of our platform. So let's duplicate this and change this to the first platform. Let's remove this and change it to the screen width. Okay, so let's duplicate screen 1 and change it to the screen width. So as you can see here in our output, so we have the screen 1 width. And for the mountain, so we have the mountain sprite, so the width should be duplicate screen 1 dot width multiply by 0.85, so that is the 85% of the screen width. And for the mountain height, we'll set the mountain height to the mountain width. So let's have the mountain sprite. So mountain sprite width multiply, or it should be divide by 2. Mountain sprite width divide by 2. So let's refresh to remove the error. And the next is for our platform width, platform 2. So let's duplicate this. So we have the platform 2 sprite width, right? So it should be the same as the platform sprite, the first platform. And for the height, it should be the same also for the first platform. And the next is for our the mountain X. So this will be the position of our mountain. So for the mountain X and Y, so this discussing first what's the X and Y. Right, so in our Photoshop, so we have here, I'll explain what's the purpose of the X and Y. So we have here the two lines. So this one, this vertical line, this is for the y, and this horizontal line, this is for the x position. So in here, as you can see here, we always start with 0. So we have the 0. So this will be the position of our 0 if we have the screen 1. So in here we have the 0. So this will be 0x, or x equals to 0 and y equals to 0. As it goes down, so the y also goes up. The value of y goes up depending on the value or the size of your screen in pixels. So the x will always be 0 in this side, and the y will always be 0 at the top. And we go on the left, so the x pixel will also be add according to the size of our screen. So this will be the position. And if we add a sprite, right? For example, this is a sprite. So the position of the x and y can be found in this part. I'll be using elliptical. For example, so this will be the position of your x and y. Alright, this is the circle. So this is the position of x and y. For example, so we start with 0. So the position of your let's have this as the y as 500, and for the x, for example, 320. Alright, so in here, so as estimation, the position of our x should be from at least to 320, 160. For example, is 80. Okay, this is for our y or x, and for the y, for example, the position of y is, so from 250, half, so half of the 250 is 125. So this is the position. So you should remember what is the position of your x and y. So let's continue with our MIT App Inventor. So let's go to the mountain sprite. So set the mountain sprite x to the screen 1 that width. So that's the screen 1 that width. And for the mountain y, okay, should be let's have a minus on our map. It should be on the platform that y, so the first platform, minus the height of our mountain. So mountain height. So it will depend on the position of the platform y. And then next is for the cloud x and y. So I'll make this duplicate. So let's change it to the cloud sprite .x. So there you go, our cloud. And for the cloud y, cloud sprite .y. So set the, or let's have the screen height. Okay, let's have a multiplication. Let's duplicate this and change it to the screen height multiplied by 0.2. So this will be the position of our cloud. And next, for our platform, let's duplicate this and change it to the first platform. So our platform sprite should be 0, or the x should be 0. And for the platform 2.x, okay, it should be the platform x minus the first platform this will be the platform y. I'm sorry. So platform sprite.y is platform.x, or screen 1, sorry, the screen 1 dot height minus the platform height. So let's have the platform height. So this will be the position of our platform.y. The screen 1 dot height minus the platform dot height. And for the platform 2, that's sprite, platforms 2 sprite.x, it should be the platform.x plus, let's have a plus, platform.x plus the platform width, platform sprite.width. And for the y of our platform 2, let's duplicate this, and platform 2, remove this. It should be the platform dot y. So this should be height, not heading. So that's for the mountain sprite, that height. Okay, so the reason that's why the platform is not visible, because the platform to that sprite doesn't have the picture, so we have to also upload or insert the platform.png. So as you can see here, we now have our platform. The next is for the play button. So as you can see here, the Mario is not around, or it's not in our screen. If we make it through and refresh our companion app, so it will not be visible because of the position of the Super Mario. And then let's make it on false. And for our next start button, so we will also set the start.x to screen height. So just like in our cloud, so we have the cloud sprite that width. So we have to duplicate this for the X. So screen height, and for the Y, it should be the width and the height. Let's say for the width 1.5. There's the play button, and for the Y, let's say 0.5, or at least 0.4 our play button. And let's make it a little bigger. So instead of 40, change it to 80 pixels, and for the width also 80 pixels. Okay, so this will be our play button. For the position, let's adjust that later. The next is, let's have a loading time. So initialize a variable. So this will be for our loading clock. I just make this on our loading clock timer. So let's have a loading times and set the value to 0 as the initial value of the loading times. So what will happen here is, let's remove the initialize screen, and let's have a if then else in our control. So in our if then else, let's have so if our global loading times, okay, this is the variable, is less than to 5, so what will happen, it will set the loading time to +1. Times +1, and then let's call the initialize screen. Else what will happen, it will make our loading clock to false. So set it to false. So we're done with our first initialize screen, right? So next is for our start game. So what will happen if we touch our play button? So let's have another procedure, and rename the procedure to start game. So next is to make our start button to disappear or invisible. So let's have the start button visible to false, and let's have the Mario sprite to visible true. The next is we'll set the Mario height, the Mario sprite, that height is equal to the screen height. So let's multiply the screen height, screen 1, that height, times, duplicate this to 0.1. So let's try later on for our touch button. The next is for the start button. So what will happen if we touch the start button? and let's call the procedure which is the start game, so we can able to try to touch. Alright, the next is for our Mario width. This will be for the width of the Mario, and let's remove this. So let's have another mat, so this time division. It should be 0.50, or it should be 2. We'll divide the Mario height, Mario sprite, that height, divide by 2. Right, let's see the position of our Mario. If you click play, let's make the Z to 5. For the X and Y of our Mario, let's set first the X to the, so let's remove this, and let's have a multiplication. So we have the canvas width, so canvas 1 that width multiply by 0.55, so that's the 55% of the canvas width. And for the Mario sprite.y, let's have the, let's remove this, let's have a minus, and another minus. It should be the canvas 1 that height, canvas 1 that height minus the platform that height. So we have the platform sprite that height minus our Mario height, Mario sprite that height. So that will be the position, or the Y position of the Mario sprite. So we try it. So that's the position of our Mario. The X is 0.55 of the canvas width, so this is the position 55% of the canvas width. And for the Y, it should be the canvas 1 that height, so this is the height of the canvas, and minus the platform height, so this is the platform height, and minus the height of Mario. This is why this is our position. And the next is, so we have the, when the start button is touched, so it will call the our procedure, which is the start game. And the next, let's create the animation procedure. So to procedure, and I'll name this as animation procedure. So the first thing we will do is to animate our character, which is Super Mario. So to do that, let's have a control and if then else control, and we need to initialize a variable. So the name of the variable is frame. Set the value to 0. The next is if our global frame, or our variable frame, is less than to 3, so it will depend on how many frame you have. For example, I have 3, that's why I set my condition to 3. So what will happen? So it will set first the global variable, the global variable should be let's have plus +1, and set the Mario picture, Mario sprite, that picture, so it will change over the time to, let's have a join, so the name of our image. So this imitator, let's add a string and a text. So let's duplicate this 3, and for this let's have a letter A. So this is the name of our character, is A1, A2, and A3. That's why in the first we have the A, and let's get the value of our global frame. Then the last is that PNG, and then else. So we'll set the global frame to 0, so it will make it as a loop. So let's have this as 0. So I just put this. To see the result, let's have the animation clock, and let's call the procedure, which is the animation procedure. Refresh. Play. So we should call the animation clock in our start game. So to do that, let's have the ani clock, then timer enabled. So let's have the set ani clock, because as we do in our designer, the ani clock is disabled. That's why we need to enable it on our start game. So we need to make it true, and let's suppress our companion screen. Play. As you can see here, we have now a moving animation of Super Mario. So we have 3 image in here. So we have the A1, A2, and then A3. And after the 3, it will set the global frame to 0. Okay? So this is the first part of our tutorial. So the next part should be our background moving. So we have the mountain moving, also the platform, and for our cloud. So you need I will also upload the part 2 of this tutorial. Okay, so see you again next time, guys. See you on our part 2 tutorial. Bye bye.